So here the question was, find a point on the curve x square is equal to 8y, which is nearest to the point 2, 4. And I said let PHK be the point that is nearest to the curve x square is equal to 8y. So since HK lies on the curve, x square is equal to 8y, therefore you put x is equal to h and you put y is equal to k. You get h square is equal to 8k. Call this 1. Now what is the distance between 2, 4 and hk? Say I call this distance alpha. Suppose this is distance formula, root over of h minus 2 whole square plus k minus 2, k minus 4 whole square, okay, which is root over of expand h square minus 4h plus 4 plus k square minus 8k plus 16. Which is now you see that k is h square by 2. Okay, so let us put the value of k. Instead of putting, last time I was putting the value of h, let us put the value of k. So h square remains as it is, 4h remains as it is, 4 plus 16 becomes 20, and k square, since we are putting the value of k, what is k from here? K is h square by 8. Because see, if we put h is equal to root k, again you're becoming a radical inside a radical. So better to avoid that, instead put the value of k. Okay, so this becomes k square is h square by 8 whole square minus 8, k is h square by 8. Okay, this. So this becomes completely an expression in h. So h square minus 4h plus 20 plus h to the power of 4 by 64. And this 8 cancels, you get minus h square. Okay, so again this h square and this h square, they cancel. So what do you get? You get alpha is equal to you get here root over of you instead what you do is you get alpha is equal to this, right? So keep it as it is. Instead of simplifying, we'll differentiate it as it is. It will be easier to differentiate. No point simplifying. Okay. So therefore, for local maxima or minima, what do we have? D alpha dh must be equal to 0. So now if you differentiate this, first we'll differentiate the radical. So 1 by 2 root of the radical, whatever is there in the radical, you have h to the power of 4 by 64 minus 4h plus 20. Okay, into the ddh of h to the power of 4 by 64 minus 4h plus 20 is equal to 0. Okay, so now what happens? Denominator, if this is equal to 0, that means ddh of h to the power of 4 by 64 minus 4h plus 20 must be equal to 0. Now you differentiate this, you get 1 by 64 into 3h square, 3h cube in fact, sorry, 4h cubes. 4h cube minus 4 is equal to 0. Now this will cancel 16 times. So how much are you getting? You're getting h cube by 16 minus 4 is equal to 0. That means you are getting h cube by 16 is equal to 4. So you're getting h cube is equal to 16 into 4. Now 16 is what? What is the power of 2?
Sir, 64
2 to the power of 4 into 2 square, which is 2 to the power of 6. So therefore h cube is cube root of 2 to the power of 6, which is 2 to the power of 6 by 3, right? From the law of indices, this cancels. You simply get
Yes, sir.
h2 square, which is 4.
Yes, sir.
In fact, this is h. Okay. So h you are getting 4. Now what should be the value of k? What should be the value of what is k here? K is h square by 8. Therefore, k is equal to h square by 8. Now what is the value of h? 4 square by 8, which is 4 into 4 by 8. So you're getting k is equal to 2. Now the point is whether h is equal to 4, at h is equal to 4, comma k is equal to 2, we get a local extrema. Whether maxima or minima, I don't know, right? We get
Yes, sir.
a local extrema. Now how will you find out the whether it is maximum or minimum? You calculate d2 alpha dh2. Therefore,
Sir, what is extrema, local extrema?
local with instead of writing minima or maxima, I'm writing extrema. Okay. Local extrema means either minimum or either minima or maxima.
Okay, sir.
So d2 alpha dh2 is what? D alpha dh. We got this, right? So d2 alpha dh will be okay. Now this is now this c d2 alpha d alpha dh is equal to 0. We have got d alpha dh is equal to this, right? Isn't it? Now see, in order to calculate d2 alpha dh2, that is why in the beginning only I was saying if you can square the relation, right? If you remember yesterday, I was saying that instead of differentiating alpha, you can write this as alpha square is equal to h minus 2 whole square plus k minus 2 whole square, right? If you remember, this is what I was saying. Then maximization of alpha means maximization of alpha or minimization of alpha square means maximization or minimization of alpha also, right? So therefore, d2 alpha dh2 is very difficult to calculate from here. Okay. So what you do is you can skip the second derivative here. Okay, you can say obviously it'll come to be a minimum. Okay, you can say at at h is equal to 4 d2 alpha dh2 is negative. Because see, in the problem only they have given minimum, right? In the problem only they have given minimum. That means you will not get a maximum. Maximum distance means what? If I take a point on the curve and if I say maximum distance, what does it mean? Maximum distance can be anything, isn't it? Maximum distance of the curve from the point can be
Yes, sir.
infinity also, right? See this diagram that I have drawn here.
Yes.
When I talk about minimum distance, okay, we can calculate. But if I say of P, the maximum distance of any point on the curve from 2, 4, that this curve extends till infinity, right? This extends till infinity. All these two
Yes, sir.
branches extend till infinity. So it cannot be the maximum distance. Therefore, without even differentiating, you can say that at h is equal to 4, d2 alpha dh2 is less than 0. So therefore, h is equal to 4 is a point of local, no, in fact, greater than 0. Sorry, this should be greater than 0, not less than 0. Because we are talking about minimum, right? We're talking about minima. The second derivative has to be
Yes, sir.
positive. So at h is equal to 4, this is a point of local minima. And therefore, the required point is 4, comma 2. So we have got our answer. Okay. Do you understand this problem?
Yes, sir.
Now, yesterday I showed you one applied problem. Okay. Let us see another applied problem. Now, in example, you have some very good problems. The approach may be different. My approach may be different, but in the example, you'll get the same answer. Okay. My approach may be a little different from the examples, but you will get the same answer. Yesterday, I showed you how to show that when a rectangle is given and the area of the rectangle is constant, then how to prove that that rectangle is nothing but a square, right? That is what I showed you yesterday. One problem. Let us see another problem here. The problem number 21. The length of the perimeter of the sector of a circle is 20 centimeter. Okay, the length of the perimeter of the sector of a circle. Let us consider a circle here and say this is the sector of a circle and the perimeter of the sector is given to be 20 centimeter. Perimeter of the sector is given to be 20 centimeter. Okay, so it can be any sector. What do you mean by perimeter of this sector? Perimeter of this sector means this length radius plus length of this arc. Do you agree with this?
Yes, sir.
Sir, can you explain once more? I
Perimeter
haven't
of the
understood.
perimeter of the sector. What does the perimeter of the sector mean? Perimeter of the sector means this length plus this length plus this length, right? This is what it means, perimeter of the sector.
Yes,
Yes.
sir.
So that is what you need to understand. Perimeter of the sector means these three. Okay. So now if the perimeter of the sector is this, then let's say that the radius of the circle is r. Now, as I told you earlier also, that first you need to check which is your maximizing or the minimizing function. Okay. So let's read the problem first. Give an expression in the area of a sector in terms of r. So now you need to write the expression in terms of area of the sector in terms of r. and hence find the maximum area of the sector. So what is the maximizing function here? Maximizing function? Maximizing function is area of the sector, right? Say A, area of the sector.
Area of the sector.
If I take the radius of the circle as r, okay, and if I take this angle as theta, then what should be the area of this sector? If you remember in class 11 trigonometry when I was starting, what was the area of the sector? Half r square theta. Do you remember? Where theta is in radians. Remember this relation or not?
Yes, sir.
No, sir. Or
Yes.
what?
If you don't, then please remember this. That
I
if this
forgot.
angle is given in radians, theta, and if the radius is r, then the area of the sector will be half of r square theta. And also one more relation I had given, that if the radius of this circle is r, and if this angle is theta, what is the length of this arc here? The length of this arc is r theta. If you remember again
R
your
theta.
from your class 11 trigonometry knowledge. Okay, so maximizing function is this. Next, what is the auxiliary function here?
Happy.
Auxiliary function,
Sir.
perimeter of the sector is given,
Sir,
right?
sir.
Perimeter is equal to 20. And what is the perimeter of this sector? R plus what? R plus R plus R plus R plus R theta, right? This length plus this length plus this length, right or wrong?
Yes, sir. Yes, sir.
Which is equal to 20. Okay.
Sir, the screen is up.
What? I could not get you. What are you saying?
Sir, the screen is disappeared.
You log out and log in once again.
Okay, sir.
Okay, so you have R into 2 plus theta is equal to 20. So what is the value of R here? R here is 20 by 2 plus theta. Now what did I say? That you will have to maximize or minimize the function with the help of the auxiliary function, right? So what you do is the value of R that we have calculated here,
Yes,
20
sir.
by 2 plus theta, you have two variables here, right? R and theta in the area, in the maximizing function. So you bring it to a single variable by putting the value of R. Therefore, what is area here? What is area here? Half R square. Put the value of R. From the auxiliary function, you put the value of R in the maximizing function into theta. Yes. So now we have got area in terms of theta only, right? So what will happen? Just simplify this a little. Half 400 by 2 plus theta whole square into theta. This is what you're getting, right? So you cancel here.
Yes, sir.
So how much do you get? You get 200 theta by theta plus 2 whole square, right? Now for local maxima or minima, what will you have? dA d theta is equal to 0, right?
Yes, sir.
That means now put the what is the value of A? A here is 200 theta divided by theta plus 2 whole square. This must be equal to 0. Now how will you differentiate this? First of all, take 200 out. That means 200 dd theta of theta by theta plus 2 whole square is equal to 0. Now, how will I differentiate this? What is the best way to differentiate? U by V rule. Yes, tell me.
Yes, sir.
You can use U by V rule, but I use a little different here. What you do is you have theta on top. I add plus 2, right? And I subtract 2. And then I write this as theta plus 2 whole square. Okay. In fact, this 200 will not be there. This 200 will not be there. Okay. Is equal to 0.
Okay.
Now it becomes easier to differentiate. Instead of using U by V rule, it becomes easier to differentiate. Now if you separate, you will get 1 by theta plus 2 minus 2 by theta plus 2 whole square. Remember this method or not? The differentiation of this is minus 1 by theta plus 2 whole square. The 1 by x differentiation is minus 1 by x square. Minus, and differentiation of this would be minus 2 by theta plus 2 whole cube. Right? Nx to the power of n minus 1 rule. Okay. Now what you do is you take the LCM. Theta plus 2 whole cube. So what do you get? Minus theta plus 2 plus 4 is equal to 0. Right? So what do you get here?
Yes, sir.
That means minus theta plus 2, because the denominator cannot be equal to 0. So then therefore, if the fraction is equal to 0, then the numerator is equal to 0. Cross, or you can say cross multiplying. That means what do you get? Minus theta minus 2 minus 4 is equal to 0. That means you get minus theta is equal to 6. That means theta is equal to minus 6. Okay, so at theta is equal to minus 6, area is maximized or minimized, right? So now how to check
Yes, sir.
whether it is maximized or minimized? How to check whether it is maximized or minimized?
Sir, from second derivative.
Second derivative. How will you find out the second derivative of this?
Sir, d2y upon dx2 is equal to the value
D2A
of that
d
one.
theta 2.
Yes, sir.
D2A d theta 2 is dd theta of dA d theta,
Yes.
which is, now what is dA d theta? dA d theta is this one. Um, dA d theta is your this one. Okay, this one is your dA d theta. So dd theta of minus 1 by theta plus 2 whole square plus 4 by theta plus 2 whole cube. Okay, so this is, how will you differentiate this? Minus 1 by x square. What is the differentiation? dd theta of minus theta plus 2 whole to the power of minus 2 plus 4 theta plus 2 whole to the power of minus 3, which is, how will you differentiate this? Minus of minus 2 into theta plus 2 to the power of minus 3, and this is minus 12, 4 into 3 12, theta plus 2 whole to the power of minus 4. Okay, this is what you get, the value of d2 8 d theta 2. So you get 4 theta plus 2 to the power of minus 3 minus 12 theta plus 2 to the power of minus 4. Now what was the value here at theta is equal to minus 6? What is the value of d2 at d theta 2? Put it in this expression. 4 times minus 6 plus 2 to the power of minus 3 minus 12 into minus 6 plus 2 to the power of minus 4. Is this positive or negative? Tell me, is this positive or negative?
Yes, sir.
d2 at d theta 2, is
Yes,
it
sir.
positive or negative?
D.
Minus
Sir,
6 plus 2 is
positive.
negative.
Sir, positive. Sir, positive.
Why positive?
Huh?
Why positive?
Okay, sir.
Why positive? Tell me.
Sir, I thought the negative sign was not there. That's
Huh?
why.
It has to be
I thought,
negative.
sir, minus 6 was.
It
That's.
has to be
Yes, sir.
negative. So therefore, this is negative. That means at theta is equal to minus 6, A is maximized, right? And what is the maximum value?
Yes, sir.
Yes, sir.
You need also to find out the value of R at theta is equal to minus 6. Okay, what is the value of R at theta is equal to minus 6? You use the auxiliary relation to get the value of R. Which one is the
Okay, sir.
auxiliary relation? This one. R is 20 by
Yes.
2 plus theta. R is equal to 20 by 2 plus theta. 20 by 2 minus 6, which is 20 by minus 5, right? So we're getting negative answer here.
Yes.
I'm talking about the x h
Huh?
square k minus t whole.
What? I can't hear you. Tell me, repeat again. Huh?
Hello.
Yes,
Sir,
tell
k
me.
minus h.
K
Sir,
minus.
k minus h.
Why will I introduce another H?
Hello. H.
See, K is a constant here because it is given, right? So K is a constant. So what I do is I write P as it is because see, K is a constant. This is a constant. P is, so I get only A in terms of only P, right? Did you understand? K is a constant here. In fact, this, even though you can see that P is
Hello.
there, even though you can see K is there, actually P and K are constants. Understood? So therefore, what is meeting is supposed to end, okay, in 2 minutes. Okay, so what I do is I stop here. Now,